Good afternoon. Thank you for joining me today at this presentation. My name is Leslie Klein. I am the President and CEO of CCOM Satellite Systems. I'd like to give you an idea of what we do and basically what type of business we are in. When you have questions, please let me know and we're happy to answer them. So there is the CCOM disclaimer for the presentation. The company started the company 27 years ago. It's a company that has 33 people, publicly traded on the Toronto Venture Exchange and the OTCQB. Company pays dividends, which is very unusual for a technology company, but we have been doing it for 10 years. And yield is about 4.2% as of last quarter two. The company itself is a manufacturer of on-the-pause communication, satellite communication antennas, which essentially deliver high-speed internet into vehicles while on the pause. So you can push a button and the robotic antenna finds any satellite anywhere in the world and delivers instant communication within minutes. Normally it takes an engineer about an hour and a half to 2 hours to find the right satellite with the right equipment, connect it, and get it going. So this technology makes it possible for oil and gas companies, for example, to move from place to place within minutes or hours and not rely on a specialist to operate the system. Anybody can push a button and find a satellite. The company has sold over 10,000 of its antennas over the number of years. We have into 106 countries, through a very large distribution network of 600 plus active resellers and dealers. We have 41 different models of antennas. We support 10 modem manufacturers, plug and play, and there's 12 different sizes of antennas from 60 centimeters all the way up to 2.4 meter. And we support different models. Some are drive-away, which sit on top of a vehicle. Some are fly-away, which can be transported in transportable cases, and then we have MEMPACs, which are under 25 kilos, and they are packable into a small bag, and you can carry, one person can carry it on their bag, and also have fixed motorized antennas, which I'll show you some pictures so that you can see what these antennas look like. The company has $25 million of working capital. We have paid out over 10 years $25 million in dividends to shareholders. Over 49 consecutive quarterlies, and the company has no debt. It has never borrowed money, and it operates without any debt. The markets that we address are pretty much wherever internet is required today, and it's mainly commercial markets, governments, military, emergency response, oil and gas, cellular backhaul, mining, schools, broadcast, even mobile banks. I'll show you some pictures of these applications, and you will see these vertical markets that the company has products around the world. So this is a map that shows basically some of the antennas, some of the 10,000 antennas that are deployed. Interestingly enough, you can see that most of them are in areas where cellular coverage is pretty easily available, like North America, Europe. And of course, we have quite a number of them in Japan and China, and in the Middle East. Some of the areas that you don't see is because the antennas are behind the firewall, so you cannot see them. But interestingly enough, you can see New Zealand. Every fire department in New Zealand has one of our antennas. So the whole New Zealand is pretty much covered. Wherever there's a fire department, there is an antenna on a fire department. So these are the different platforms. You can see the drive-aways, they sit on top of a car, and they go from 74 centimeter all the way up to 1.8 meter. And the flyaways that can be taken apart without any tools and put together within 5 or 10 minutes. They are all the way also up from about 70 centimeters, 74 centimeters to 1.8 meters. And then the MEMPAC that I mentioned before, that is carbon fiber, very light, can be carried by one person, and again put together without any tools. Most of these antennas operate through different satellite operators, and they all require different configurations. So we have the same antenna operating on many different service providers like Eutelsat, Hughes, Viasat, Yasat, and Thor 7, and many others. They all have different configurations, but essentially they are the same antenna. So we can build 100 of these antennas and sell them to different satellite operators and let them operate over their network. This is an SNG antenna, so you can see it's different from the others. It's a very elegant looking antenna designed for satellite broadcasting, for television stations and news broadcasting. It has a cowling that makes it look aerodynamic. It's Eutelsat approved, and quite a few of them are sold all over the world for broadcasting applications. This is a flyaway. Again, shows the transportable cases that they fit into. They come apart without any tools and could go put together without any tools. So you can put them on a helicopter, or you can put them on the back of a truck and carry them to a location. Within 10 minutes, you are up and running, having high-speed internet connection. This is the MEMPAC that I mentioned that fits into that backpack. You have the controller also on the part of the whole system. It's all carbon fiber, very light, 24 kilos, and it comes apart in 5 minutes, goes together in 5 minutes, and finds the satellite in 30 seconds. So anybody can use it. Anybody can take it with them to any location where they want connectivity and operate it. They come in different sizes, shapes, and also we have sold it to the military. So you can see it's same antenna, but it's painted green because the military required us to paint it green, but it's the same antenna. And it operates, and it's about half the cost of a mil-spec antenna. It's not mil-spec, it's commercial, but it operates the same as a mil-spec antenna. This one is just actually used in the Rockies to generate or produce a video. They were using it for advertising, to shoot an advertisement up in the mountains. Actually, it was a Volvo ad. I don't know if you've probably seen it on television. This allows, the antenna to be taken up to the mountain, set up with a power source, and the video can be transmitted directly to a studio for editing, so that they can shoot, a video and actually finish it while up in the mountain. They don't have to bring it down and edit it, but they can actually retransmit it, and then they can re-edit it and reshoot it as many times as required. So it saves a lot of time and a lot of money. This is an application of the MEMPAC in Japan for disaster recovery. We have sold 400 of these antennas to SoftBank, where they have tsunamis and typhoons and many other disasters where they lose cellular towers. So this antenna becomes a cellular tower, and somebody can carry it with them and operate it instantly when they lost a cell tower connection. And so here are some of the major applications of the antenna. Oil and gas is very big. You can see them in different parts of the world. China, Libya, United States. Halliburton has over 1,000 of these antennas on these type of vehicles, and they're used very extensively in oil and gas exploration. News gathering, as I mentioned before, is very large also. Different types of antennas in different parts of the world, used to deliver news instantly from a location up to the studio so that they can transmit the news directly into the studio from a location, and essentially just the reporter has a vehicle to their disposal to report the news. Emergency response is police, fire, disaster management. On the left there you can see the Japanese Osaka Fire Department has 20 of our antennas that they use for delivering instant communication from a fire, so that they can command different forces to fight the fire. Also SoftBank, when there was a major disaster in Japan, they bought a couple hundred antennas, vehicle mount antennas, to actually replace their cell towers during the tsunami that happened in Japan. Telehealth, we have mobile breast cancer screening units, mobile surgery units, mobile ambulances. Even during the COVID, we had a vaccination clinic that had the antenna on it. So again, it provides life-saving capability to those who need this type of technology. The military is another customer. Obviously, we have the Russian, Polish, Chinese, American military who have used the antennas. We cannot sell to Russia anymore, but before we could, and there were quite a few of these used for military communications. The telecom companies for cellular backhaul are buying a lot of these antennas. As I mentioned, SoftBank is one of the largest users altogether with about 600 antennas, 400 MEMPACs, and a couple of hundred vehicle mount antennas for disaster management. Mobile offices, these are interesting e-government applications where you can see, for example, on the left, the government of South Africa has 113 of our antennas for printing pension checks. So these vehicles go out to remote areas of South Africa and deliver pension checks to pensioners so that they don't have to either wait for the mail or go to whatever cities to pick them up. On the right, you can see in Argentina, the government of Argentina equipped 30 trucks to print passports. So that's a similar type of e-government application for passport printing where they can travel around the country and actually print government IDs and passports to those who need them. And mobile banking, most people would be surprised to know that there are vehicles that carry mobile banking capabilities. In South Africa, again, there is vehicles that have no cash, but they refill the cell phone with cash, so people can pay with their cell phone. And these vehicles are again traveling around South Africa and make it available. We have them in Hawaii, in Barcelona, in other parts of the world, and also in Germany. You can see this very large vehicle there that's used as a test vehicle to establish locations for permanent testing of ATMs. And the vehicle is there for about a week, and if there's enough traffic, they put in a permanent ATM location in that location, but it's used as a test vehicle. So the next generation of satellites, I'm sure you have heard a lot about SpaceX and OneWeb and Amazon Kuiper of Bezos, his new venture, and Telesat, who just received a large amount of money from the Canadian government to launch their light-speed low Earth orbit satellite constellation. So we have 6 years ago started developing an antenna that will work with low Earth orbit installations, satellite constellations such as the Telesat, for example. And we have received funding from the Canadian government and from the university. I used the University of Waterloo to develop this technology. So the antenna, as you can see, it's an electronic antenna, the size of a Canadian quarter, and it's modular. So you can put those together into a panel and have an electronic antenna that actually does not move. It's similar to a PC. It has electronic components on the back, and it will form a beam and track a moving satellite. So this antenna was developed in 2021, and it's being finished now we are testing it on a vehicle this month, actually, and it should be finished. The testing should be finished next month, and we should be in production sometimes next year of this antenna. So the antenna is modular, it's conformal, it can actually scan 360 degrees, and it will track a moving satellite even if your vehicle is moving. So you can be in a vehicle that's moving and a satellite that's moving, and the antenna will track electronically the moving satellite. So the market for this type of technology is fairly large. It's about $17 billion, and it's going to be growing very rapidly, mainly for government, military, and commercial type of applications, for planes, trains, buses, vehicles, all of that. And you can also use them for radar, development of radar, and many other applications that will be coming. There'll be over 50,000 LEO satellites. Right now, there is about 10,000 of them up in the sky, and so it's growing very rapidly. Amazon is going to put up 33,000 themselves, and SpaceX has about 6,000 of these satellites in the sky. This is what the antenna looks like. You can see it's combined from small elements into a larger panel, transmit-receive panel, and that's what the antenna looks like actually. You can see the comparison between a parabolic antenna that's probably 100 pounds to an electronic antenna that's about 20 pounds or less, 100 kilos compared to 20 pounds, 20 kilos. And it's flat, nothing is moving, and it sits on top of a vehicle or a plane or a train or a marine vehicle or a marine vessel. So this is the flat panel market penetration rate that's estimated to be by 2033. You can see that the government, military is, and the enterprise is a large chunk of the information. And the flat panel industry is going to be growing very rapidly. This is what it looks like on a car. This is what it would look like on a train. And this is what it would look like on a plane. Again, the antenna will operate in any of these environments as long as somebody actually develops the packaging of it to put it on these vehicles, trains, buses, whatever. And so here you can see the constellations. As you can see, all those satellites, they're moving, and they're covering pretty much the whole world. And they are, you can see the Telesat constellation is much less dense. It has only 188 antennas, sorry, 188 satellites, compared to some of the large 6,000 and more thousand antennas that are used in the consumer type of application. So the commercial application, like the Telesat application, is going to be less, but the bandwidth is going to be 10 to 100 times greater than the existing consumer type of solutions that are out there. So CICOM is also developing the ICs. These are the beamformer integrated circuits that are behind these antennas. And we should have this technology developed and on the market sometimes next year. There is over 2,000 of these integrated circuits per antenna. And they're very important in the development of the phased array antenna because there's very few companies in the world that are manufacturing this. And they have to be very cost efficient and power efficient to be able to reduce the cost and increase the performance of the beamforming of the satellite antennas. So it just shows you, gives you an example of what these chips look like. They're 8-channel chips, and they are pretty much like the integrated circuits that you see in your computers. And we hope to be able to be in this business also next year. And the market for this business is supposed to generate up to $4 billion in revenue over the next 10 years. There is only very few companies, actually there's only one company in the world that makes these integrated circuits, and they're very expensive, and we hope that we'll be the next one who will have a product on the market at a significantly less cost and a significantly higher performance. So this is the forecasted market. Today it's about 250 million, and it will be over 412 million over the years for this integrated circuit. We hope to sell that IC to others and use it also in our own antennas. So that's my presentation, and thank you very much for your attention. Any questions, I'll be happy to answer. We sell only through resellers. We have 600 resellers in 106 countries. So we don't sell directly to end users, and it's all done through the resellers. The resellers do the installation, the support, the maintenance, and the warranty. Sure. Can you repeat the question? Yeah, I'm not sure if that's correct. Yeah, there wasn't such a huge growth. It was pretty flat actually from year to year. About, we do about $10 million to $12 million, and we have a 65% gross margin. That's correct. The second question is if the antennas have a lifespan. They normally last quite a bit, quite a while. Unfortunately, depends on how long how often they're used. But in general, they are For example, the Japanese don't use them very much. They only use them during disasters. So that product could last probably 15 years. There's no technological changes required for it to be used. As long as they use the same service, the same modems, the same transmitters that they use, then there's no change, and they can keep using them. What was the second question? The only recurring revenue is spare parts and also technical support that we provide, but it's insignificant. It's not much compared to the rest of the revenue. Any other questions? Yes. The competition is almost diminished now. It's hardly anybody is left because of the technological changes that are required and the amount of money that is required to keep this business going. Our model is different from many other companies. We don't manufacture anything. Everything is outsourced. So anybody who was manufacturing this type of equipment is no longer in business. They can't afford to stay in business. And so the only competitors we have, they are not really competitors. They are people who sell to the military, and they have very specialized military spec products similar to ours, but they don't venture into the commercial marketplace because of the cost. Those antennas are 2 to 3 times more expensive than ours. The other advantage that we have is we have about $8 million worth of inventory, so we can ship hundreds of antennas within months. Most others who have been in business cannot do that. They take 4 to 6 months. And so when you have a disaster, you want to be able to deliver product right away. The dividend is not changed for 10 years. We hopefully generating more cash than we need, and we still have about $17 million, so we are giving it back to the shareholders. And I'm one of the large ones, so I have no problem taking it. But obviously, if the cash flow, reduces to maybe 10 million or less, we'll have to think about it. But I believe that we can maintain this because we have very good margins and we have a steady revenue base from these legacy products, and we hope that the new antenna will generate additional revenue for us that is not accounted for at the moment. Yes. It's 4.1%. It's not bad for a small company. No, it stayed the same for the last 10 years. Any other questions? No. We want to make sure that we can continue paying for the development for R&D. And we're also getting some money from the government, significant amount of money, so we are plowing it all back into the University of Waterloo for the continuous development of these technologies, where this technology is being developed. And we own all the IP. University gets the cash and gets some PhD students out of it. So it's a very good arrangement. Yes. Probably sometimes next year, towards next year, end of next year. We are in a manufacturing process now of the electronically steered antennas. So that will take a while for that process to get ironed out, and also to get volume production up and running. But there's a lot of companies that are very interested in doing this for us. So we are seeing a lot of large semiconductor manufacturing companies who want to be able to get into this business coming to us, and they are having conversation about how they could manufacture large quantities of these antennas. In Taiwan. Yeah. But we are hoping to find somebody in Canada. So it would be nice to bring it back home, but I don't think at the moment we have not been able to find anybody yet, but maybe we will. Anything else? It's very difficult. I mean, it's painfully difficult because the stock is probably the same price as it was 27 years ago, and we had nothing, so it's frustrating to be public, actually. It's like, yes. So it's, it's very difficult, and since we don't raise money, it becomes a problem. Nobody looks at you because you don't need any money, and they will not promote us unless we borrow money, but we don't need money. We never have. Somebody will buy us. Yeah, they have to, because this technology is becoming very hot. So yeah, we spent 6-7 years developing it, and so somebody will have to, somebody who wants this technology will not spend 6 years developing it. So it would be cheaper for them to buy us than for both. Yeah, the ESA and the beamformer, both are very hot. Yeah, I think I'm told to knock it off. So thank you very much for listening, and be happy to answer any questions. I can give you my business card if you have any questions. Thank you very much.